Hi everybody. Today we'll be solving a vectors problem. As you know, vectors are really important in physics and also in mathematics. So the question says C is equal to A plus B. They're all vectors. And C's magnitude is equal to A's magnitude, which is equal to B's magnitude, and they're all equal to 1. So C, A, B are all unit vectors. They all have unit magnitudes. So the question is, what is the angle between A and B? So this is a vector addition, right? So as you may recall, we do not add vectors like scalars, right? So 1 plus 2 is equal to 3, but for vectors, 1 plus 2 is not always equal to 3. This is important. So a good physics student can solve this problem, but a great physics student solves this problem using different methods. So rather than solving this problem, our main focus here is to go over different methods. So we're trying to come up with different methods to solve this problem. Okay, and in the end, you will see that even geometry helps us solve this problem quite easily. Okay, so let's move on. So they say, what is the angle between A and B? So since there is an angle between A and B, these two vectors are going to define a plane, right? By the way, A and B cannot be parallel or anti-parallel. Why not? So A plus B gives us C, right? So if A and B are parallel, let's suppose they are pointing in the same direction. They're pointing in the same direction. So A and B, right? So A plus B gives me 2, right? The magnitude of 2. So if A and B are in the same direction, I can simply add the magnitudes to find the magnitude of C. So this would give me 2, right? So if A and B were anti-parallel, A is in this direction, B is in that direction. So A plus B will give me 0 vector. So C would be 0. So since C has a magnitude of 1, these two vectors, A and B, cannot be parallel or anti-parallel. By the way, it's a good exercise in the morning, right? Anyway, so let's start with the first solution. So we'll be using a coordinate system. So I already know that, so this is my first solution. I already know that A, let's say A is like that, and B is like that. They are not parallel, anti-parallel, so there's an angle between them, theta. So they define a plane, two vectors which are not linear, they define a plane. Okay, so now I can choose a coordinate system, but how am I going to choose it? So I have the freedom to choose my x and y coordinate system, right? So I can choose any direction, let's suppose this direction, and call it x, and another direction y. The only requirement here is these two coordinate axes are perpendicular to each other. Okay, good. So why did I make this choice? Because now with this choice, A will not have any y components, right? And there will be no other angles introduced in the problem. So it's going to simplify the question quite a bit. So here I can find the components of A and B. So A is going to be equal to, only has x component. I can call it x hat. Okay, how about B? B is going to be equal to B cosine theta x hat plus B sine theta y hat. However, we know the magnitude of B is simply equal to 1. So this is simply 1. So now I can write the components of C, or C vector in general. So in x, I have 1 plus cosine theta x hat plus the y. A has no y component. It's just sine theta y hat. Okay, so from this relation, I know that c's magnitude square would be equal to 1, which is equal to square of the x component, which is 1 plus 2 cosine theta plus cosine square theta plus square of the y component, sine square theta. From the cosine and sine identities, you know that this is equal to 1. Cosine square plus sine square is equal to 1. But I already know that the magnitude of c is equal to 1. So this side, left-hand side, is also equal to 1. So 1 is equal to, so 1 plus 1 is 2. 2 plus 2 cosine theta. So from here, what I can find is cosine theta is equal to minus 1/2. So theta is equal to 120 degrees. And this is the answer. So using a coordinate system, this is how we can get the right answer. So now next step is to use the dot product. So let's see how it works. So okay, for the next solution, we will be using the dot product. So we do not need any coordinate system, but we'll be using the definition of the dot product. It's a really powerful mathematical tool we use a lot in physics. So A dot B. So let's remember the definition. So what is A dot B? So magnitude of A times magnitude of B times cosine of the angle between them. So this is how we define the dot product between two vectors. Okay. So now as we see, A dot B is equal to B dot A, right? Because we can always switch these two. So A times B is equal to B times A. So cosine theta is here. So B dot A is equal to B times A times cosine theta. So from this relation, and simply say that A and B can be switched. The order doesn't matter. So A dot B is equal to B dot A. Okay, so we know that C is equal to A plus B. So if I do the dot product of C with itself, what do I get? So I will get A plus B dotted with A plus B. Okay, so what is C dot C? So C times C, well, cosine 0, right? The angle between C and C is just 0 degrees. Cosine 0 is 1. This gives me C square, which is equal to, so I'll have A dot A on the right hand side, which is equal to A square, plus I have B dot B terms, B term B square, plus I'll have A dot B and B dot A. But as I mentioned before, they're equal to each other, so I can simply write 2 times A dot B. So this is the cross term. So we know that C squared is simply equal to 1. These are the magnitudes, right? So 1 is equal to 1 plus 1 plus, because A and B are also 1. These are unit vectors. So it's going to be equal to 2 times A dot B is equal to magnitude of A, which is 1, magnitude of B, which is 1, times cosine of the angle between them. Cosine theta. This angle theta is now the theta in between A and B. Okay, in the end, I'll get cosine theta is equal to, this one cancels this one, minus 1/2, right? Same answer. So theta is equal to 120 degrees. Okay, very good. So the last method is going to be quite nice. So you will really enjoy that, I think. So let's move on to the next solution. Now we will solve this problem using geometry and the property of adding vectors. So let's suppose I have a vector like that, A. Okay, so now I have another arbitrary vector, B, like that. But how do I add them? A plus B, right? That's what I want to find. We simply use the tip to tail, or sometimes tail to tip, they call it tail to tip or tip to tail, whichever way you want to say it, doesn't matter. So we take the first vector A as is. So A is pointing to the right. So I'm just going to take it like that, A. So here is the tail and here is the tip of A. So then, without changing the orientation of the second vector, B, I'm moving it. So I'm connecting the tail of B to the tip of A. So as I said, the orientation or the point B directs doesn't change. So A is also pointing its usual direction. So B is also pointing in the same direction as before. So we just connect them like this. Tail of B is connected to the tip of A. So the resultant, or the sum, of these two vectors, A plus B, C, can be found by connecting the tail of A to the tip of B. Here we go. So I know that A is a unit vector, so it has unit magnitude. So B has unit magnitude 1. So I want to create a C vector which will have unit magnitude. Well, if this is 1, this is 1. And if the orientation is like this, right? C cannot be 1, right? So here the idea is I'm going to fix A and I'm going to rotate B. Okay, I'm going to move B until this C becomes 1, right? So by the way, as you see here, if we have two vectors like that, if I calculate A plus B, if I want to create a C vector by adding them, I always form a triangle, right? That's why I've been using a lot. We actually use a lot this triangular identities when we are adding vectors. So I want to create a C vector which unit magnitude. So I will have sides of this triangle with unit magnitudes, right? So I'll have 1, 1, and 1. Oh, okay, so what kind of a triangle is that? Yes, what kind of a triangle is that? Equilateral triangle, right? So this is 1. So B is going to be like that. So this is A. So this is 1. So this is C, right? So it should have magnitude 1. So if this is the case, this angle here would be 60 degrees. This is 60 degrees, right? All the internal angles. So A is pointing in that direction. So B is pointing in that direction, right? So A is pointing that direction, in that direction. B is pointing in that direction. So the angle between them would be 120. And this is the answer. So as you see, there is not a unique way to solve problems in physics. This was a nice example, okay? So in some cases, even using geometry or the visualization, our ability to visualize actually helps us solve the problems in physics. I hope you enjoyed it. I'll try to solve more problems like that. As you see, getting a solution is one thing in physics, it's important, but being able to apply different methods, being able to solve a given problem in different ways is actually more crucial on the path to become a physicist. So I hope you enjoyed the video. I look forward to seeing you next time. Take care. Bye.